Hello friends, in the previous two lectures we have seen what is meant by leveling, what is the principle of leveling, what is the object of leveling, and what is the purpose of leveling. Then in this lecture we are going to see how to determine the RLs by making use of the two methods. So in this slide we are going to see the two methods, namely Collimation System, or it is also called as height of instrument, that is HI method, or rise and fall method. First of all, we are going to see the collimation system or collimation method, in which the reduced level of line of collimation is said to be height of instrument. In this system, the height of line of collimation is found out by adding the backside reading to the RLF benchmark, on which the BS is taken. Then the RLF intermediate points and the change points are obtained by subtracting the respective stop reading from the height of instrument, that is HI. The level is then shifted for the next setup, and again the height of line of collimation is obtained by adding backside to the RLF change point, which was calculated in the first setup. So the height of instrument is different in different setup of levels. Two adjacent planes of collimation are correlated at the change point by an FS, that is foresight reading from one setting, and a BS reading from the next setting. It should be remembered that in this system the RLF unknown points are to be found out by deducting the stop reading from the RLF height of instrument. So here in this slide you are going to see first of all the figure 5.24, in which there are two positions of instrument and the stop stations are at benchmark at A, B, C, D. So here when the instrument was set up in between A and B, then first reading was taken on the benchmark, and generally since it is the first stop reading, we are going to call the stop reading as backside reading. So backside reading is the stop reading which is taken on the point of known elevation, and benchmark is a point having known elevation of 100. So 100 plus 1.255 is the height of instrument, therefore it is 101.255 when the instrument was set up in between A and B. Then the stop reading at A was taken, it is 1.750. Similarly at B it is 2.750. So in order to calculate the RL of A, we have to subtract the IS reading, that is 1.75, from the RL of HI, that is 101.255, to get the RL of A. Similarly, in order to calculate the RL of B, we have to subtract the stop reading, that is 2.750, which is the last stop reading taken from this particular setup. So therefore this particular reading can be entered or considered as foresight reading, and therefore RL of B can be calculated as 101.255 minus 2.750. Then the instrument was shifted to the position in between the stations B and C, and when the instrument, after carrying out the temporary adjustment, again the stop was held at B. And since at position B, BS as well as FS both readings are taken, therefore the point B is called change point. And at the BS for the second setup, the stop reading was taken was 2.150. And previously from the first setup we have calculated RL of B. So to the RL of B, that is RL of CP, we are going to add the backside reading to get the new RL of HI when the instrument was set up in between the station B and C. And after calculating the RL of height of instrument, that is 101.855, we can calculate the RL of C as well as RL of D by subtracting the respective stop reading from station C and D from this particular RL of HI. That is RL of C equal to 101.855 minus 1.950. Similarly, RL of D equal to 101.855 minus 1.550. So that way we can calculate the RL of C as well as RL of D. So in this slide we are going to see rise and fall method. In this method, the difference of level between two consecutive points is determined by comparing each forward stop reading with the stop reading at the immediately preceding point. If the forward stop reading is smaller than the immediately preceding stop reading, a rise is said to have occurred. The rise is added to the RL of preceding point to get the RL of forward point. Similarly, if the forward stop reading is greater than immediately preceding stop reading, it means there has been a fall. The fall is subtracted from the RL of preceding point to get the RLR forward point. So for that we are going to refer the figure 5.25. So in the figure 5.25 we will observe that the instrument position is in between station B and C, and the stop were held at benchmark A, station B, station C and station D. So first of all we are going to consider what is the stop reading at benchmark at point A, B, C and D. They were 0.75 on benchmark, 1.25 on A, 2.75 meter stop reading on B, 1.5 on C, similarly 1.75 meter at D. So by making use of that we are going to calculate the rise or fall. So just we have to subtract this, or just we have to subtract the stop reading at A from the preceding stop reading. So at point A, 0.75 is the stop reading which is taken on the benchmark, and 1.25 is the stop reading on A. So in order to calculate whether there is a fall or rise at station A, we have to take the difference between these two stop readings, that is 0.75 minus 1.25, that is minus 0.5. Similarly at point B we have to consider what is the stop reading at B as well as what is the stop reading at A. So 1.25 is the stop reading at A and 2.75 is the stop reading at B. So 1.25 minus 2.75, that is minus 1.5, that is to say that there is a fall from A to B. So therefore it is minus. Similarly, when you are considering the rise or fall at point C, you are supposed to compare the stop reading on B as well as stop reading at C. So when you take the difference between the two stop reading, that is 2.75 minus 1.5, you may get plus 1.25. So there is a rise from B to C. So here again, in order to calculate the rise or fall at D, you are supposed to compare what is the stop reading at C and what is the stop reading at D. So 1.5 minus 1.75, that is minus 0.25 is the fall. So after getting the fall and rise at respective station, we can calculate the RL of benchmark. So whenever there is a rise, we are supposed to add the rise to the preceding RL, and whenever there is a fall, then we have to subtract the fall from preceding point to get the RL of forward point. So here the RL of benchmark is given, that is 100. Then in order to calculate the RL of A, we are supposed to consider what is the fall at station A. So 100 minus 0.5 equal to 99.5. Similarly, RL of B equal to, we have to consider the RL of previous point, so that is A. So 99.5 is the RL of A, minus we are supposed to consider what is the fall at point B, that is minus 1.5. So you may get RL of B as 98. Similarly, in order to calculate the RL of C, you are supposed to consider RL of B, that is 98, and you are supposed to consider the rise at C, that is 1.25. So 98 plus 1.25 gives you 99.25. Similarly, in order to calculate the RL of D, you are supposed to consider the fall at point D. So 99.25 minus 0.25, that is 99. So whenever you are considering this particular method, you are supposed to apply the arithmetic check, that is summation Bs minus summation Fs should be equal to summation rise minus summation fall should be equal to last RL minus first RL. So this way the readings are to be checked. So in this slide we are going to see what are the points of comparison between collimation system and rise and fall system. In case of collimation system, it is a rapid system, it involves few calculations, whereas in case of rise and fall method, it is laborious and it involves several calculations. In case of collimation system, there is no check on the RL of intermediate points, whereas in case of rise and fall method, there is a check on the RL of intermediate points. Then when we consider the collimation system, errors in intermediate RLs cannot be detected, whereas in case of rise and fall method, error in intermediate RLs can be detected as all the points are correlated. There are two checks on the accuracy of RL calculation in case of collimation system, whereas there are three checks in case of rise and fall methods. In collimation system, is suitable for longitudinal leveling where there are large number of intermediate sites, whereas the rise and fall system is suitable for fly leveling where there are no intermediate sites. Considering the above points, the rise and fall system is always preferred as there is no possibility of error in calculation of RLs in the intermediate points. Then next we are going to consider what are the points to be remembered while entering the level book. The first reading of any setup is entered in the BS. The last reading in the FS column and other readings in the IS column. Second point is a page starts with a BS reading and finishes with FS reading. If a page finishes with IS reading, the reading is entered in the IS and FS column on that page and brought forward to the next page by entering it in the BS and IS column. The FS and BS of any change point are entered in the same horizontal line for change point. The RL of line of collimation is entered in the same horizontal line in which the corresponding BS are entered. Important note is benchmark and change points should be clearly mentioned in the remark column. Hello friends, in the previous two lectures we have seen what is meant by leveling, what is the principle of leveling, what is the object of leveling, and what is the purpose of leveling. Then in this lecture we are going to see how to determine the RLs by making use of the two methods. So in this slide we are going to see the two methods, namely collimation system, or it is also called as height of instrument, that is HI method, or rise and fall method. First of all, we are going to see the collimation system or collimation method, in which the reduced level of line of collimation is said to be height of instrument. In this system, the height of line of collimation is found out by adding the backside reading to the RLAP benchmark on which the BS is taken. Then the RLAP intermediate points and the change points are obtained by subtracting the respective stop reading from the height of instrument, that is HI. The level is then shifted for the next setup, and again the height of line of collimation is obtained by adding backside to the RLAP change point, which was calculated in the first setup. So the height of instrument is different in different setup of levels. Two adjacent planes of collimation are correlated at the change point by an FS, that is foresight reading from one setting, and a BS reading from the next setting. It should be remembered that in this system the RLAP unknown points are to be found out by deducting the stab reading from the RLAP height of instrument. in this slide we are going to see another problem on reduction of levels, in which the stop readings were taken at an interval of 20 meter and the instrument was shifted after 4th and 8th reading. So therefore, if you consider the page of level book, you will find that there is station point, change, BS, IS, FS, rise and fall, RL and trimmer. These are the columns, and here 4th reading is 3.45, it is entered in FS column. Similarly, 8th reading is 0.985, so it is to be entered in FS column, and last reading, that is 3.63, it is entered in FS column. And immediately after 4th reading, whatever the 5th reading is to be entered in BS, and 9th reading should be entered in BS at the same level of FS. So therefore, in the remark column you are supposed to enter as change point, and then you can calculate the rise and fall. So whenever you are calculating the rise and fall, you are going to consider the difference between the two, first and second. So when there is a difference positive, you are going to enter in the rise column. If the difference is negative, you are going to enter in the fall column. And whenever you are going to calculate the accuracy of leveling, then you have to apply the arithmetic check, that is summation BS minus summation FS should be equal to last RL minus first RL should be equal to last RL minus first RL. Thank you friends. In this lecture we have seen the two methods of reduction of level. One is rise and fall method and second is height of instrument or collimation plane method.